So in this problem, we have that a telephone line hangs between two poles that are 14 meters apart. So in part A, we have that the equation of the telephone line follows y equals 20 cosine h of x over 20 minus 15. So in part A, we need to find the slope of the telephone line along with the right pole. So how do we do this? Well, in order to find the slope, we need to find the derivative. And in order to do this, we need to basically put the equation of y in terms of x and y only and get rid of the h. So if you remember from your textbook, we know that the cosine of h equals e to the x plus e to the negative x divided by 2. However, in our case, we need to know that x is actually equal to x over 20, as you can see in this box right here in the red. Okay, so what does this mean? We can basically put all together the equation y equals 20 times e to the x over 20 plus e to the negative parentheses x over 20. And while we're starting out, it's important to put the parentheses since this is a negative of the whole x value, not just the x. So this is all divided by 2 minus 15. So we have our final equation. However, we can go one step further and simplify it by saying that 20 divided by 2 equals 10. So now that we have our final equation, we can put this into derivative form. Now, if you know how to take a derivative, it's basically taking the 10 as a constant, multiplying it by the e to the x over 20 times 1 over 20, since the derivative of the exponent is 1 over 20, plus e to the negative x over 20 times negative 1 over 20, as follows by the previous e to the x over 20. And all of this, we can say, is equal to the y prime derivative. So what we can do further with this is that we know that the x value has to be 7, as you can see in this drawing, because the x coordinate on the right pole is 7. So we can basically plug in 7 for x into the derivative equation here to get 0.3572 as the slope for part A. Now let's move on to part B. So in part B, we are given that we need to know what the theta as you can see in this drawing of the black angle right here is. So how can we do this? Well, in this problem, we can basically see that the blue angle right here is equal to 90 degrees. Namely, it's a right triangle. So we can use that knowledge and see that there's a complementary angle to theta, or the black angle. And this is the red angle. Let's name it theta 2 for this problem. All right. So, as you know from all right angles, we know that 90 minus theta 2, the right angle, equals theta because of the complementary property of right angles. So, what we can do is take the slope from part A, which was equal to sine h of 7 over 20, due to the derivative of cosine h, 7 over 20, being sine h, 7 over 20. So we can take that part A and say that the slope or tangent of theta 2, or the red angle over here, is equal to that slope found in part A. So when you rearrange everything, you essentially get that theta 2 equals the inverse tangent of sine h of 7 over 20 to isolate theta 2. So now that we have our theta 2 angle, we can basically say that we have all the parts needed to find theta according to this equation right here. So what are we going to do? We are basically going to put that theta equals 90 degrees minus the inverse tangent of sine h of 7 over 20. And this is all one section indicated as theta 2 right here. So this is all theta 2. Now, if you remember from part A, you know that that part A, sine h of 7 over 20, or the slope that we found, was 0.3572. So what you can do is put in your graphing calculator in degrees mode, since we're using the 90 degrees instead of pi over 2, which would be used in radians mode, and do 90 degrees minus the inverse tangent of sine h of 7 over 20, or the inverse tangent of 0.3572, and this would equal 70.34 degrees, or theta. So that's the answer to part B, and that's how you do the question.